Okay, so picture this. You're an AV integrator. You're setting up this amazing corporate boardroom.
Right.
You've got the huge 85-inch touch display. The 4K camera is perfectly centered. Everything looks beautiful. And then you realize
Uh-huh.
the computer running the whole show has to be in a server closet, like way down the hall.
We keep the fan noise out. And suddenly you have a massive, massive problem.
Yeah.
Because your USB cables, they just have a really strict distance limit. We're talking 3, maybe 5 meters before the signal just, well, it falls off a cliff.
Physics is a harsh mistress, isn't it?
Yeah.
But today, we're looking at a piece of hardware that claims to just bypass that limit entirely.
It does.
We're doing a deep dive into the DVDO Xtend-USBC-USB-100, our mission today. Figuring out how these professional setups move huge amounts of data across a building without, turning a video call into a pixelated mess.
And it is a very specific tool for a very specific headache. This device takes a USB 3.2 Gen 1 signal, and that's high bandwidth. We're talking up to 5 GBps, and it just throws it 100 meters.
100 meters. That's, what, nearly 330 feet?
Yeah, exactly.
Okay, so let's unpack that, because I know a standard USB cable can't do that.
Yeah.
So is this using some kind of, I don't know, super thick proprietary fiber optic cable that costs a fortune?
Surprisingly, no. It's actually using HDBaseT technology, and it's running over a single standard CAT6A cable.
Wait, just a normal Ethernet cable?
The same kind that's probably already running through the walls of almost every modern office building.
I always thought HDBaseT was, well, wasn't that mostly for video distribution?
It is, yeah, but the technology is all about convergence. It takes video, audio, power, control signals, and it modulates them to run over that copper cable without the latency you'd get from, say, a normal network switch.
So you're basically tricking the data into traveling a highway it wasn't built for.
That's a great way to put it. Yeah, and without hitting any traffic lights.
That's a game changer for retrofitting older buildings then. You don't have to rip open the walls.
You just use the existing network lines.
But does it play nice with older gear? Like if I plug in a 10-year-old mouse, is it going to work with that shiny new 4K camera?
It does. It's fully backward compatible with USB 2.0 and 1.1. So all your legacy stuff works right alongside the high bandwidth devices.
Looking at the specs here, this isn't just a simple in and out extender, is it? It looks more like a distributed hub.
That's the best way to describe it. You have a transmitter unit and a receiver unit.
Okay.
The transmitter sits with your PC, but that box also has extra USB ports for local stuff. Then, 100 meters away at the receiver, you've got 2 USB-C and 2 USB-A ports just waiting.
So I can have, what, 4 or 5 different devices plugged in at the far end of the room, all feeding back to that one computer in the closet.
Exactly. And you do it without installing a single driver. It's completely plug and play.
Which is huge in a professional environment. You can't ask the CEO to download software just to use the room's camera.
No, absolutely not.
Okay, speaking of the room setup, what about power? If I have the receiver unit hidden behind a TV on the wall, do I need to find an outlet back there? Because those are always scarce.
This is one of the smartest design choices they made. It features bidirectional power over cable.
Bidirectional. So it works both ways.
It means you only need to plug the power supply into one unit, either one. If you have an outlet near the PC, the transmitter sends 24 volts down the Ethernet cable to power the receiver.
Or the other way around.
Or if the closet is full, you power the receiver in the room and it sends power back to the transmitter.
That is huge for installers. Now, I saw a term on the spec sheet that, I'll be honest, it sounded like marketing fluff, but I have a feeling you're going to tell me it's important. Isochronous transfer.
It sounds like it, but it's actually the most critical part of this whole thing, especially if you care about video quality.
Okay.
So standard data transfer is called bulk. It cares that the data arrives, but not really when.
Like a file download. If it pauses for a second, no one notices.
Exactly. But if a video feed pauses...
You notice. You get stuttering, or the audio desyncs from someone's lips.
And that's what isochronous transfer prevents. It reserves a dedicated sort of lane for that time-sensitive data. It ensures video frames arrive in a steady, unbroken stream. This device even uses hardware acceleration to prioritize it.
So that's why this thing costs $599. I was going to ask why you wouldn't just daisy chain a bunch of cheap repeaters.
And that's the difference. Daisy chaining, it introduces jitter, latency, points of failure. When you're equipping a surgical suite or a broadcast studio, you're paying for the guarantee that the signal arrives perfectly every single time.
It's infrastructure, not an accessory.
That is the key takeaway. It completely decouples where the user is from where the computing power is. You can design the room for the people, not around where the computer has to sit.
So here's a final thought for you to mull over. We're all used to being tethered to our desks, right? By the length of a cord. But if you have bidirectional power and a 100-meter range, where could you actually move your workstation?
I'd put the noisy computer in the basement and have my monitor out in the patio.
Sounds like a plan. Thanks for diving in with us. We'll catch you on the next one.